Hi everyone, let's talk Galileo. Galileo was a friend of Kepler's, a bit older, and Galileo's brilliance was that he added reproducible observations by telescope to Kepler's laws and mathematical equations. This supported Kepler's equations into becoming more mainstream and, in effect, bringing the Copernican revolution up to scale. And it supported that by supporting the heliocentric view that Copernicus was talking about. So the book does a very good job of the political layout of Galileo's work, but I really wanted to talk to you about the scientific layout of his work. Galileo did not invent the telescope, but he was the first person who really utilized it. And the telescopes were invented in the Netherlands right around 1600. By 1606, it was in Italy, and it was being used and perfected by Galileo. If you consider the 1600s, a 5-year span to get scientific knowledge across hundreds and hundreds of miles is quite a feat, and it speaks to the revolution that was growing in that time at the end of the Middle Ages. There were 4 things that Galileo observed and set the tone for that really supported Copernicus and supported Kepler. One was the observations of the moon. Prior to this, the moon was supposed to be perfect. It was up in the heavens. It was created by God. It was supposed to be perfect. Galileo was the first to use his telescope to make drawings to show that the moon was not perfect at all. These are his actual drawings. Well, a copy of them. On top of that, let me move this up here. Galileo was the first to show that the sun was not perfect. And not only that, but to show through sunspots, which had been seen by the Chinese hundreds of years before, but that knowledge didn't get to Italy. But through sunspots, Galileo was the first to show that the sun rotates. That was huge. The sun had been seen as an object that was stable in the sky and perfect in the sky. But these are some of the drawings that were done. They were inspired by Galileo, but within months of Galileo's work, it was being replicated by other astronomers. Third thing, Jupiter's look at the moons, Galileo's look at the moons of Jupiter meant a couple of things, and they go into this in the book, but I wanted to go into it a little bit more. That when he saw these moons and saw what he thought were stars around them, then he realized that the same number of stars were moving around the area. He figured that this was a moon. Remember, the definition of moon is an object which circles a planet and is non-luminous. So now he was pointing out that there were other moons besides our moon that had never been known before. And if Jupiter could maintain a moon rotating around it, then Jupiter itself was a center of motion. And the Earth could be just like Jupiter. The Earth was not special. In addition to that, what is really important is that he was able to say that the smallest moon orbit around Jupiter was also the fastest, which supported Kepler's third law in regard to the orbital period and the radius around the object. So you see how all these things are working together. Fourth thing is that Galileo was able to show that Venus had phases. Now, Venus was a favorite celestial body because it's beautiful and very, very bright. So for the time, Venus was pretty well studied, not with a telescope. Galileo was the first to study it with a telescope. In Copernicus, Copernicus actually looked at Venus right here as having an epicycle right between the sun, which of course revolved around the Earth, and the Earth. Galileo took that apart and said that if that were the case, that the sun was on a line with the Earth, then the sun would always shine onto Venus and always show the Earth a crescent of Venus. Right? And you knew by looking up at Venus that you weren't seeing a crescent, but they said the sun is so bright that this is what you're seeing. Galileo took that apart, and in doing that, he took apart Copernicus's theory as well. And he was able to show through his telescope that Venus did have phases and that the sun therefore was in the center of the universe. So that epicycle went out the window, and it was reproducible for those observations, which really fueled Kepler's work. So we talked about the moon, the sun, the Jupiter, and Venus, all reproducible observations. All of them contradicted the belief that was sponsored by the Catholic Church that the heavens were constant and perfect, and that the earth was corrupted and evil, and the center of the earth would be hell, which you can see how there is this pull away from societal constraints and toward science and toward the scientific method. Now, what are scientific facts? Again, just to review, a fact is a verifiable observation. These observations of Galileo quickly became scientific facts, and scientific facts are the foundation for a scientific theory of how an explanation of phenomena, an explanation of what we were seeing in regards to the sun's movement and the planet's movement. Excuse me, the sun's apparent movement and the planet's movement. So these observations quickly became facts, quickly became theories that were the heliocentric theory of planetary orbits. You could say that Galileo's observations became natural law, and they were backed by Kepler's scientific laws and his mathematical equations. Not a big point, but it's something I wanted to bring out to you in case you hear about natural laws. This all happened right around the 1720s, 30s. Galileo made a big point about it and was under house arrest for the last 10 years of his life. But he had started the movement that led to a scientific revolution throughout Europe. In the 1660s, things really start to move forward. And it's no surprise that 100 years later, in the 1760s, you're still feeling the impacts. We'll get into that soon. And next up is Newton.